Hey, Kins. What?
Calculator's so dead it won't even turn.
It does it take batteries? I can give you batteries.
Yes.
Yeah, hey, there's batteries sitting right over there. Kins, you need to get better. We miss you. We got to do 3 examples. And this is the last little bit of 3-4 notes. We did example 4 the other day, and I think I recorded those and sent those off to you. It's in an email somewhere. But yeah, we're starting with example 3, and then we'll move to 5 and 6. So here we go. Graphing a polynomial function. We did example 4 first because he was already broken down. This one is not already broken down. That's why I did them in the reverse order. So this one takes a little bit more work than example 4 did, but like, how do we go about breaking this thing down? Like, I need to know the bubbles and stuff. Like, he will have 3 places he crosses, true? Because x to the third. But how do I figure out what those bubbles are? Like, where do I even start?
You do the 6 over 2.
Yeah. So we do like, you could try to factor by grouping, right? And like pull stuff out and whatever, but I don't think that this bubble is going to end up matching that bubble if you do factor by grouping. So, yeah, let's do the p over q. So p would be -6, q would be 2, and so my factors of 6 would be plus minus 1, plus minus 2, plus minus 3, plus minus 6. Gross. Factors of 2 would be plus minus 1, plus minus 2. Oh, okay.
Please stop.
Okay, so then we make our like little groupings. So 1 over 1 is plus minus 1. 2 over 1 is plus minus 2. 3 over 1 is plus minus 3. 6 over 1 is plus minus 6. Plus minus 3, plus minus 6, okay? But then I got to do it with 2, right? So now I start again with 1 over 2 is plus minus 1/2. 2 over 2, that's nice because that's 1 and we already have 1, so we don't have to add it twice. 3 over 2 is plus minus 3/2. And 6 over 2 is plus minus 3, and we already have him. So we have, these are my possible ones. How many are there?
1, 2, 3, 4, 5, 6, 12.
12 with all the pluses and minuses. So we have 12 possible ones, right?
The last one, plus minus 2/3.
Plus minus 3/2.
3/2.
3 over 2. Yep. 1.5. 1.5. Okay. So now what do we do?
Negative.
Plug them in. All right. Do we want to divide and conquer?
Yeah.
I will do, I don't know how many of there's 5 of you. I'll do the hard one. I'll do 3/2, plus minus 3/2. Anybody want to be brave and do 1/2?
I'll do
You
it.
just do 0.5, what?
I'll do it.
Okay, Connor's got this one. Who else?
I can do 6. I'll do 3.
Okay, Ellie's got 6. Aiden's got 3. You got 2. Okay, you got the easy one, Aubrey. You got plus minus 1. Okay, so plug those guys in here. What are we looking for?
0.
0. And I just gave my calculator away, so now I gotta find a calculator. Because I can't do those in my head. Oh, here we go.
How much are these calculators?
It depends. If you get like an older, like this one is technically an older version. That one's a newer version. I think those are like 145 or something like that.
Negative 2 works.
-2 works? Yeah.
Negative half is a no-go.
Negative
Oh.
1 doesn't work.
-1 does not work. Okay. You guys are all doing the negatives first?
I did both.
You did both? Okay, so positive 2 doesn't work? Okay.
It's supposed to be 0, right? If it works.
Yes. Yes.
Both halves do not work.
Okay.
I don't think either of the 6s work either.
Either the 6s work.
I got like 200 numbers.
Oh no. Do you want me to do some of the 3 over 2?
Yeah.
I mean, you can, but as soon as I do one of them, it's going to be easy to do the other one. Minus. Okay, 3 over 2, positive doesn't work. No, I'm going to insert my negative.
Negative 3 over 2 works.
Negative 3 over 2 works. Perfect. Okay, we got 2 of them. Aiden, did you get any of the 3s to work? Aubrey, did you get positive 1 to work? No. So none of yours work? None of the 3s work? Okay, so
We have,
here's what I'm guessing.
so we have 2 and what?
We have -2 and -3 over 2. So here's what I'm guessing. One of those
It's a
repeats.
touch.
Yeah,
Not a
which means
cross.
it has multiplicity of 2, which means it's a touch point. I'm going to guess that they repeat. Because we have 2 and we need 3, I'm going to guess that we don't have any imaginary ones because imaginary ones always go in pairs, like the conjugates, right? If you have a positive imaginary, you have to have the negative imaginary, and that would give us 4. So that's not going to work. So I'm going to guess that one of these repeats. So how do we figure out what the third one is? Let's divide.
The 6 out, or the 2 out.
The 2 out first. I like that idea. So let's put negative 2 here. I'm going to do 2, and we don't have any zeros, right? 2, 5, negative 1, negative 6. Okay, 2 goes down. That will be negative 4. This will be 1. That will be negative 2. That will be negative 3. That will be positive 6. That will be 0. Okay, I did that really fast. Negative 3 halves. Okay, 2 goes down. Do you know what negative 3 over 2 times 2 is? Negative 3.
3.
Negative 3. Yeah, yeah. And that makes negative 2, and that times that is going to be positive 3, and that is 0. Hey! Okay, somebody was wrong. Aubrey was wrong.
That's why I'm redoing it.
Yeah. So this guy is 2x minus 2. Okay?
The positive 1 works.
Yeah, the positive 1 works. That's the deal.
That's what I thought.
Yeah. Yep, you're fine. Okay, so this was my last bubble, right? Okay, but what I'm going to do is instead of writing it as 2x minus 2, I'm going to write that as 2 times x minus 1. Can I do that? Like I'll pull that out, right? Okay, and then my other 2 bubbles, what would this bubble look like with the negative 2?
X plus 2.
X plus 2. Do you know what the bubble looks like for negative 3 halves?
X. 2x.
2x
2x. Plus 3.
plus 3, right? That would be negative 3 over 2, right? Okay, so my places where he crosses are at 1, at negative 2, and at negative 3 halves, okay? And what's this 2 do out in front?
Makes him tall.
Just makes him taller. I'm not really worried about that. So if we go to graph this guy, his parent function is x cubed. Do you know what x cubed looks like? He looks like this.
Opposite way.
Right? He looks like one of those, okay? And he does cross at 3 places, so those 3 places are going to be like those 3 places, right? Okay, so that's what we've got looking like. We've got negative 2, which would be this guy right here. Negative 3 over 2 is negative 1.5, so that's right close together. And then 1 is my other guy. Okay, can you visualize what this thing's going to look like?
Hold on.
Those are my 3 places he crosses. Negative 2, negative 1.5, and positive 1. He's going to do like one of these. Probably something of that nature. We don't know how tall or how skinny or whatever, but that is that. Something of that nature. Okay? In general, that gives us like the general idea of what the graph looks like. Okay? Oh, we do know what this point is right here. What's this point right here?
Let me look. It's negative 6.
It's negative 6 because negative 6 is the y-intercept. Yeah, so 0, negative 6. So we could add that point in there if we wanted to. Whatever. Give us a little bit more information. How do I find out, like, how tall or how steep or anything else like that?
Plug in points.
You'd have to plot points, and we don't want to do that. We just need the general shape of the graph, so that's fine. Okay? All right, let's go to example 5. Yeah. All right, here we go. I'm going to skip over the intermediate value theorem, and I'm going to do this. Okay, you ready? It says use synthetic division. I'm going to cross this out and put not synthetic division, synthetic substitution. To graph or to show that this function will have a 0 that is between 2 and between 3. All right, so here's the deal. If I'm looking at my graph here, 2 is here, 3 is here. All right, let's talk about this. I'm going to substitute, and I'm going to plug 2 in there, right? So we're going to find f of 2. Okay, and if I do f of 2, that's 2 to the third minus 2 times 2 squared minus 2 plus 1. Okay, I can do some of this in my head. This would be 8 minus 2 plus 1. So negative 1. So 2 is at negative 1. Basically. Right? 2 is at negative 1. Okay, 2 is not a 0. It's not a place where he crosses, right? Because I plugged in and I got -1, right? If I got 0, then he would be on 0, right? But he's not a place where he crosses, okay? Now let's talk about 3. If we plug 3 in, f of 3 equals 3 cubed minus 2 times 3 squared minus 3 plus 1. Okay, 3 cubed is 27. 3 squared is 9 times -2 is -18. Yep, minus 3 plus 1. -18 and -3 is -21. 21 and 1 is 28. So 28 minus 21 is 7. Okay, all right.
So it's gotta go up.
3 is at 7 right here, right? Okay, so they say use this to show that there has to be a 0, a place where he crosses between 2 and 3. Now, if I have 2 down here and 3 up here, like basically one of them's negative and one of them's positive, does it not have to cross between 2 and 3? Like that would only make sense, right? If one of the values is negative and one of the values is positive, he's going to have to be 0 at some point. That's what the intermediate value theorem says. It's kind of like a no-brainer type of thing. So if f of a and f of b, when I plug them in, like f of 2 and f of 3, ended up being opposite in sign. One of them was -1, one of them was +7. When that happens, there has to be a 0 between the two. That's just how it works, okay? So use synthetic substitution to show that that has a 0 between 2 and 3. Look, these guys are opposite sign. I don't know how you say that any more than that, right? Just your evidence of plugging them in, they're opposite signs, so 0 has to live somewhere between them. Now, do we know that it's at exactly like 2.5?
No.
No, not necessarily. In fact, I'm guessing that it's probably closer to
3.
2. Because 2 is here and 3 is up there, right? I'm going to guess it's closer to 2, maybe like 2.2 or something like that, right? But that's how that works, okay? That's what the intermediate value theorem says. Okay, last thing. Okay, do we know how to do this? Have we done this before? Or is that my trig class? Where we type this into the calculator and we say, calculator, make me an equation, go. Have we done that before?
Yeah.
Yeah. Okay, so here's the deal. We want to type this into our graphing calculator, okay? And I'll show you how to do that here in a second. But first things first, if we look at part A, it says using x equals 0 to represent 2007. So in the graphing calculator, we're not going to type in 2007 in the x column. We're going to type in 0. This is going to be 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10 and 11. Okay? All right. So we're typing all those in. Do you know where to go to type them in?
No.
Okay, so on your graphing calculator, you're going to hit the stat button. Okay, you go to the stat button. The stat button is like right to the left of your little up and down arrows. Okay, if you go to the green button, he's three over from the green button. So you have your second button, you have your green button, and then your another button, and then your stat button's right here.
How many do I have to go to?
Okay, so you go stat. If you hit your stat button, then what do you go to?
Edit.
Stat, and then you go to edit, like what it's on now. So you hit stat basically, and you hit enter. Okay? All right, and then you might have stuff already in your lists.
Go up and hit clear.
You can clear them. Clear my list. Clear my list. Okay, and then we got to type in all the junk. So starting with 0. Anybody not know where we're at?
You have to hit enter.
You have to hit enter after you hit clear. So go up to the very top. That's fine. Sometimes they're finicky. Oh, you gotta go up to like. Shoot, I went all the way down the bottom. Come on. You gotta go up to here and hit clear enter, so it's gonna clear the whole list at the same time. Clear enter. There you go. All good. Okay, so 0 through 11 on there.
After I do that one.
9, 10, 11. Okay, and then you type in the other guys on the other column. Okay.
I have it all.
Sure. Go for it.
2.7.
2.7. Okay.
2.88.
2.88.
3.17.
3.17.
3.25.
Okay.
3.35.
Okay.
3.62.
Okay.
3.64.
Okay.
3.41.
Okay.
3.35.
Okay.
3.35.
Okay.
3.49.
Okay.
And 3.50.
Okay. All right. Okay, so I enter those into my two columns. Stat enter. Input data. Step 1. Step 2. Plot and graph the data. All right. To plot. What am I doing? To plot the data.
Oh, I
Oh.
probably need to put my windows a little
Mhm.
different.
But also, you gotta turn your stat plot on.
Alright, do that.
Okay. Hold on. We'll wait till Aubrey's ready. And the boys.
What should my min be? Like 1. My max should be like,
Min 0. We got a 0 point.
and my max should be like 5. 5.
Yeah. I mean, you could have you could zoom in real close if you wanted to. Like 2 to 5. 2 to 4. Okay, so now, after you input your data, we want to turn our stat plot on. Okay, so what I'm gonna do is to turn your stat plot on, you have to go second y equals. So the blue button, y equals, and your plot should be on.
The first one?
Second y equals, yes. Your first stat plot should be
Hold
on.
on. Yeah, I already did that, right?
Yeah. So you go second y equals, and your plots are on the first one. So you're good to go. Okay. All right. So second y equals, and then plots on. Your first plot should be on. If it's off, you got to turn it on. So you got to hit enter, and you got to turn it on. Okay. Then after you're done with that, we want to change the window.
Cute. Okay.
Change window. Okay, so hit the window button. It's right next to the y equals button. And we're going to input x's and y's, right? So my x's are going from 0 to 11. So let's go 0 for the x's. We'll go 0 to 12 for the x's. So go all the way up to the top. X min should be 0. X max should be 12. The y's are going from 2.7 to 3.5. So let's go 2 to 4. We'll zoom in real close. For y min. Y min and y max, 2 to 4
It's like a little curvy curve.
on the y's. Yeah.
Wait, what's the Y or X?
X scale and Y scale, I don't really go off of that. It's just like how many units do you want it to go by? So you don't put anything. I just leave it at 1. Whatever it is. Yep, 2 to 4. We could go 0 to 5 if we wanted to, whatever, but I'm going to zoom in real close because the lowest we have is 2.7, so I'm just going to pick 2. The highest we have is 3.5, so I'm just going to pick 4. Whatever. Then hit your graph button and see if all your dotty dots go on. My dotty dots are not there.
That's so silly.
This is an error.
Boo. There we go. It says error. Okay, I know why. Dimension mismatched. Okay. Stat. If you go to stat, edit. La 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 la, and I go all the way down. You have a 12. We gotta clear him out because right now it's looking as though. Delete. There we go. It's looking as though he has a point, but he doesn't have a partner. So, there you go. Very good. Okay. All right. He's a weird curvy curve, right? If you graph him, he's got like weird stuff going on. Yeah? Like we don't even know what he's. There you go. If we graph him, I don't know. I don't even know. What parent function is he? He's like here, 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 here. Like that's what he looks like for me. I don't know. Okay, so we don't know what parent function he is. Maybe we do a cubic function that does one of those, right? Like we could do that. Or we could do a quartic function that does like one of those, right? So here's our options, right? If we do a cubic function and he looks like that, the cubic function will start down and he'll go like this, right? Okay, maybe that's what he looks like, right? Or maybe we do a quartic function in which he's making a W, right? Okay, we could do that option, okay? So that's what they're going to have us do, is they're going to have us do a cubic function and do a quartic function. So determine the, part A, they say plug it all in and determine the quadratic function that best fits. So they want us to do a parabola for this one. Do you think your parabola is going to go up or down? I know, he's not really very parabolic at all. If they do a parabola, maybe he goes down like that. I have no idea. All right, so here's what we're going to do. To make a function, step 3, to make a function. You go to stat, the same spot that you went, but you go over to calc, and then down to whatever regression you want, okay? So hit your stat button on your calculator. Hit your stat button, go over to calc, and the first part A we want is a quadratic regression. Quadratic regression. Okay, and we're going to go to calculate. And it's going to spit out a quadratic function at me.
A equals 0.013. That would calculate it.
What? It like does a whole bunch of error stuff. So you're fine. You're fine. So y equals, if you plot those numbers in there, I'll come over there. Negative 0.014 x squared plus 0.209 x plus 2.74 is what your quadratic function will be. Okay. Yeah, that's exactly what you're doing. So all you're doing is like, this is your quadratic function, and I'm just plugging those numbers in for ABC. That's it. And you just write the equation out. So if this was a quadratic function, it would look like that, like decimal coefficients and stuff, like really disgusting. Like that?
That's scary.
You'll hear it and
Oh, that's why there's.
And then you go down to quadratic regression. Yep. And it's asking, do you want to pull from list 1, list 2? Yep. You hit enter until you're down to calculate, and then you hit enter one last time, and it's going to do all that stuff. And there's all those numbers.
We
So
have
just put those numbers in for
negative
ABC. Yep, there you go. Okay. So if this was a quadratic function, then that's what it would look like. Okay. On, you made a whoopsie-doo. What'd you do?
I did the years and
Ah!
had a different value.
Yeah.
only negative 56,000.
Yeah, right.
Do that?
I mean, you can. Yeah. They just were trying to make, Matthew, they were just trying to make your life easier. That rather than entering 4 numbers in every time,
Yeah.
you're entering in like way less numbers.
You
So
entered in
totally
4
fine,
numbers every
totally
time.
fine. Your equation will be set up in years. So if we go to try to plug a number in, you need to make sure you plug it in years. We will have to convert it before we plug it in. Totally fine. Okay, now, on that same page, do you guys have an R value? Like, do you have a value that says R and R squared?
No.
R squared.
You have an R squared. Okay, tell me what your R squared value is.
On what? 0.827.
0.82755. Okay, we're gonna talk about that for a second.
Hold on.
On that page,
That page.
who doesn't have an R?
We don't.
Okay, I'm gonna get you an
We've
R.
also got negative 56,000.
I'm just built.
This lesson sucks.
Man, we have.
Okay.
Read our number. -0.013.
Okay. Now you have an R.
14
If you do it again, you don't have an R? You don't have an R?
9182.
Do either of you have an R?
Mine died again.
Take a gander at that equation.
I have an R squared.
That's what Matt.
Yeah, that's what you should have now. You have an R squared.
What happened?
See,
Go second catalog, go down till it says diagnostic on there, not that. You gotta go all the way down. Diagnostic on. Enter, and enter again, done. Okay, now you'll have an R. Is this yours?
That's
No, this is
That's
yours. Okay, so you should have an R value now. If you did your diagnostic on. Okay, let's do B and C where we repeat. So go to stat, go to calc, go down to, this time, cubic regression. Cubic regression, okay? And so it's gonna give me another equation, it's gonna spit out another one. And my,
What is that R for? Do we need that R?
well, we'll talk about it here in a second, I just wrote them down. Okay, so my cubic regression will be y equals
Oh, no.
0.002 x cubed
Negative 18 million.
minus 0.05 x squared
What did you guys do?
plus 0.36 x
this guy in.
plus 2.63, something like that, right? with,
I did it normal and then mine died again. Then again, I'm running two. By the way, you only had 2 batteries in there that worked. So I'm running 2 dead batteries
What?
and 2 live ones. that
where? There's a whole new pack sitting right there on my desk.
I didn't find it.
I'll
Right there.
show you
It's
right
right there. I
now.
can
I just-
see it.
Connor, look.
Oh, you mean underneath everything and
I
upside
know.
down.
In all fairness, my desk is a disaster, so whatever.
Thank you.
Okay, so there is that, right?
Get back to my normal person numbers.
That's what your cubic function looks like.
It is 18 million.
And if you do your R value for the cubic, what's your value for R? Squared. R squared is, I'm gonna write that down. R squared is 0.8923, I'll say. Okay? All right, part C, they want a quartic function. So like an x to the 4th power function. If I do it again, I go quartic regression, right? So I go stat, calc, quartic regression,
Y equals.
and you put the numbers in. Y equals, he's still thinking.
This is terrible.
Oh, 5.84 e to the negative 4. So 0.0000, no, 0.0006, I'll say,
No,
x to the 4th
it's a D, actually, sorry. We need our
minus
It's
0.01 x to the 3rd plus 0.04 x to the 2nd plus 0.17 x plus 2.67. No, 2.7.
0.00.
This is geometry.
Because you see at the top one, A says 5.8 e to the negative 4.
Anybody wanna know what you have? Yeah.
E to the negative 4 means like 10 to the negative 4th power. It's like standard. It's like scientific notation. So I just moved my decimal. So it'd be 0.0006.
This is geometry.
Okay, with an R squared value of
She doesn't wanna listen.
0.9293. What?
Same. We have the same R squared. Guess what Matt's E is? Since he used the ears.
What?
Like what do you think Matt's E?
E to the negative 17th power.
No.
What is it?
9.57 billion. 'Cause he used
Oh,
the
oh, yeah, because his would be big. Oh, gosh.
Yeah.
So there's that. All right, now, here's the deal. Here's what your R squared tells you. Are you ready for this?
You ever
R
seen
squared
R
was this guy, R squared was this guy, R squared was this guy. R squared, we'll learn in stats, actually, is the percentage of values that fit along that curve. So this follows the curve 83%, this follows the curve 89%, this follows the curve 93%. So, which typically is the best function? The 4th power, right? Because with a 4th power, I can do more things. Like I can change my curves, like I can alter them in such a way so that they will hit the most.
Fifth be even better.
A 5th would probably be even better, actually, because I can alter it more.
At least you have the calculator.
Can you do a 5th?
If you had to do stats without
I don't
the
know.
calculator, you'd
I don't think you can do a 5th. I think 4th is the highest it goes, okay?
That's really-
Typically, that's what will happen. Okay, so, and that's called the correlation coefficient, is R, right? Okay, so the correlation coefficient for those guys tells you which one is the best. The values of R and R squared are used to determine how well a regression model fits. The closer the R squared value is to 1, the better. Compare R squared for the 3 functions found in A through C and decide which function fits the best. Which one did we decide?
Fourth.
Quartic, the 4th. Okay, that typically is usually the way that it works. Is the 4th power function will be the best. Okay, that is that. That was like kind of a mess.
This is geometry. All the stuff from stats last year
Yeah,
is still in this one.
yeah. Oh, really? Nice, nice. So there's that. Okay. Now, why do we even bother with like putting this table into an equation? Like, why do we even do that?
We don't have to plot it.
So we don't have to plot them, right?
Because they're gonna be terrible.
But also, what if I want to know what the trend will be in 2020? Like, I don't have a data point for that. If I have this in an equation, now I can plug in 2020 and predict what's going to happen according to what has happened here, right? Or I could predict 2025. So this is called mathematical modeling. Modeling. Polynomial modeling. We make a model or make an equation from the table. There you go. Okay, I think you only have one like that, and the table is a little bit smaller.
Yeah.
So there's that. But otherwise, I think this homework is like a little bit easier. It's like mostly matching. So there you go.
So Pete, can you? Okay, you can stop your video.
Okay, I'll stop the video. Bye, kids. Get better. We miss you.